So this is our 301, and if you go to the multi and hyperspectral imaging, you will see your first activity. So let's just go through this just quickly. So click this, click. Hala, yun. Okay, and you see the PDF. All right. Do you see the PDF loading? Sorry. Ayan. Okay. Yeah, I see it. All right. So this activity, the objectives are to use the digital color histograms to segment regions of interest in an image, and you will see how color changes under varying illumination. But actually, you can ignore this second objective. It's enough that we do the first. This is for advanced topic. Actually, it will matter in the next two activities. So for now, just ignore this second objective. Okay. Uh, I'll go quickly to the bottom because it says there what you need to do. So you can select images for color segmentation and make sure the region of interest in each image is distinctly colored. And this can come from your personal collection or from images that you've downloaded from the net. Now, this lecture demo discusses 3 color segmentation techniques. So you will apply all 3 on your selected image and ROI and report on how well they perform. I expect you to explore their strengths and limitations. Because you asked for a deadline, this is just a placeholder deadline. It's due in 1 week. Again, I can give tutorials this Friday. Okay. Now, I trust that you will read this on your own, but I'd just like to give a few remarks. Okay? Malinaw naman to no? And there are sample code for a few. Okay? And then here diniscuss na yung color segmentation. Okay, if you have been a student of 186 and 187, this might be familiar. But what I did here was to explain the segmentation process as a way of modeling the histogram, the color histogram. Okay, right. Okay, so I leave you to read that. I'll stop share and I'll move on to my iPad to give a short talk about this topic. Questions ba so far? Wala? Okay, I'll stop share and I'll share from the other end. When we talk about color, digital color for now, the image when we load it in our programming software actually comes in 3 channels. So you will see it when you load it that you have actually 3 channels of the image. And typically for digital imaging devices and digital image capture devices, you have only 3 channels, red, green, blue. When you look at the red, green, blue channel of a true color image, they look like grayscale images. Pixel per pixel, same pixel location, okay, tells us what is the redness, the greenness, the blueness, or the intensity of the red, green, blue light on that pixel. Therefore, if we look at an image, a digital image, we can think about the distribution of the color. So, an image with a scene whose nag-enjoy ako mag-color dito eh. So suppose, for example, you'd like to segment a scene where there's some red apples and some green apples, and you want to pick out uh, the ripe ones. This is a simple example. There are far more complicated examples in real life. Since ripe apples would appear red in some varieties, then you could use color segmentation in that case. The color is first sampled. So in the example program embedded in your notes, you are to crop a portion of the region of interest. So this is our object of interest, or this is our region of interest, and it's distinguishable by color. From this region of interest, you can form a color histogram. There are actually many ways of displaying the color histogram. Basically, you can go on right ahead and display the RGB. Sorry, just to be consistent with my drawing. Okay, suppose we have RGB. Okay, so imagine ninyo maraming pixels to, and each pixel would have an RG value. Okay, RGB value. Now, if several other pixels have the more or less the same pixel value, then in the color histogram, the frequency of this value occurring, uh, would be large. In fact, if we look at the color histogram as is, actually it's a 4D graph, because kung pwede sanang ma-display natin yung number of pixels dito in some way, then that means having the same RGB value. And that means actually this color histogram in RGB color space, which is 3D, would be a 4D. Okay? We could represent it in many ways, but it's not needed. Okay? However, we can also represent the color histogram separately. For example, we can take a look at each of these channels, all right, and display their histogram, or how many pixels have that red value. Okay, so number of pixels. Now, you may be familiar with grayscale histogram. Now, typical digital images would be 8-bit. So, for example, if it's 8-bit, so the grayscale range of the red channel would be 0 to 255. And once you crop this image, you can plot it and perhaps see that the histogram would something look like this. Okay, you do it separately for the green and blue channel, and you might, for example, green, and you might see something like this, and also for the blue. Okay. Okay, right. So that's one. You treat them separately, but technically it's in 3D. So it's like, if you look at it here, if it's 2D, perhaps we can draw it in 2D first. Let's consider red and green muna. And let this axis be the number of pixels. So in the green channel, say it looks like this, parang ganito siya. And in the red channel, bandang dulo siya, it's like this. So those pixels here are actually parang they're in that spot there. Okay. Now of course, you can change this to R versus B or G versus B, and parang meron kang parang bundok dito indicating the number of pixels. As you may know, we can also think of them as, rather this histogram as joint probabilities. Pwede naman natin kunin tong histogram na to and combine them with this. Okay? And to be able to have a model or describe the model of this color histogram. Okay. Now, in the first technique, which is thresholding, we're modeling the histogram roughly like a cube. So if you look at the drawing in the text, ito kunyari yung histogram natin ng apple natin, nandito yung red pixels. We are assuming by hard thresholding na yung colors are within this cube. Okay? In the second technique, so this is simple thresholding. Essentially, we just give the range. So R should be between this and this. G should be between this, this and this. B should be between this and this. Okay, so therefore you get a cube. Okay, you can also parameterize that histogram. So that same histogram, okay, so the the pixels are here, or rather the pixel distribution is here. And when you're parameterizing, of course, you have to select your distribution function. Of course, our favorite and simplest would be Gaussian. Therefore, you can imagine that there is an ellipsoid that is modeling the distribution of the colors here. Okay. And the last technique, so this is parametric segmentation. We're not limited to no, we're not limited to Gaussians. Other radial basis functions are also just as good. Okay, if the distribution looks like that function though. And the last or the third technique is you just use the histogram as is. You use the histogram. It's anyway the color distribution itself, and you use the histogram as itself the model. No need for parametric modeling. You use it as is. Now this technique is very useful. This last one is called non-parametric. It can be used in many different ways. It has many applications on parametric. Okay, and it can be done very quickly. This is the technique that we will use here is histogram back projection. And from the idea of back projection, what is this? So imagine that each point here in the histogram has a value which indicates how many pixels have that combination of RGB. All right. So the histogram back projection works this way. Again, initially you have made a model, or rather you have made a histogram of the region of interest or the color. So it's this. It's just that here you parameterize it, okay, and here you just leave it as is. In histogram back projection, since you know that each bin here has a value, this is what you do. Take this pixel, take a look at its RGB, look for the RGB value here. So for example, its R is this, its G is this, and its B is this. So in this space, mukha siyang ganito. The location in the color cube is this. So this pixel has this location in the RGB color cube. But in this location, there's no histogram. The histogram is here. And so the value of the histogram at that location is 0. And so you back project this value in that pixel. That's 0. Or you can have a template matrix the same size as the image and same location here. So RGB value, you look for it here. You look for it, this RGB value in this space, and you find it here. Whatever is the value in this histogram, you bring it back to that same location. All right. So it's either 0 or some value pertaining, or rather equal to this bin. So if it so happens that one pixel falls on an RGB value within this distribution, you just take a look at what is the value of that pixel, or rather that histogram, that bin in the histogram, and you enter it here. So if this is 0, this might be a high number like 1000 or something, whatever the bin value is. Okay, and you do it for all pixels, and therefore what you would see is if the color of that pixel lies within this distribution, and you just return or back project the value of this distribution on that pixel. That's why it's histogram back projection. So it's merely a lookup table. That's why it can be made fast. All right. So the technique shown in the activity makes it even faster by reducing the number of color channels and limiting it to chromaticity coordinates, right? Okay, okay. So essentially that's it. Do you have any questions about this activity? So just compare the three, thresholding, parametric, and parametric. Wala ba? Raised hand si Romil E. Yes,
Hello,
please.
ma'am. Question
Oh,
po, how do we select the how large or how wide the ROI should be for a
very good
particular
question.
image?
Sige. Now, we will use the remaining time for demo. Okay? Okay, I'll stop sharing from this side and open my uh, other computer. Well, actually, that's one parameter that you can explore, Romil. Uh, Short answer is the more samples, the better, because the more you can uh, uh, inclusively uh, uh, no, the more you can include several pixels uh, uh, of the same color as the object. So the more, the better. Okay. Now let me share my MATLAB screen, and please take a look at the um, uh, text, because I'll just copy paste some of that. Right? Okay. All right. Here we go. Sharing the screen on my MATLAB. Ito. Wala. Share screen 1. Okay. Here. Okay. So let's now, this is a nice technique to allow you to simply choose your image. So user interface get file is a MATLAB code that will allow you to choose any control C, control C, yeah, any file. So if we control B that, and that's it. Now put it in the MATLAB and I can run this. Oh, by the way, you can also put sections in MATLAB by putting two percentage signs like this. In this way, you can simply run the section. Say, choose an image. Okay? And our next section would be yung sa baba. So let's run this section. So if you don't want to run the rest, just run this section. Go ahead, run that. And let's pick an image. Right. I sent in your Uble an image of the Macbeth chart. Saan nga ba yun dito? Wait lang. Okay. So please play along if you see it. So it's saan nga ba yun? Naalala. Bata. Ito. Yeah. Okay. There. Yan. So these lines display, or rather allow you to get the image, and then allows you to read it and show it. So please note that it shows up in a different window. So if you don't see it pop up, please take a look at MATLAB and you will see that there are two layers there. So you just pick that layer. Okay? Teka, may chat. Ano sabi na yun? Hello ma'am, is this session recorded? Ikaw lang. Oh, recorded. Okay, yeah, recorded. Next. All right. So the next section allows you to crop a region of interest. Okay? So let's copy that, copy and paste. And here is where Romel's question will matter. Copy. Okay. Paste. Yan. Okay. Then I'll just put another section. All right, let's run this yellowed out section. All right, when you crop in MATLAB, so earlier actually I tried this, so I know it works. What you do is you take your mouse, you pick a selection, and then go ahead and drag it, and then right click and choose crop image. Okay, please remember that. So this subsection displays the histogram separately of RGB. Okay, so see here, right? Okay, iba yung pinik ko kanina nung nag-test ako. Kaya ngayon, magmamano-mano tayo. I mean, I will take a look kung anong values nito. Could somebody take note of this? So up here, you see, you can do some data tips and check out kung anong values dito. Anong value ba nito? Tinatakpan. X, 194. Could somebody note that sa chat siguro? 194? Or roughly, I don't know, slightly over 194. Maybe over here. X 180, right? So from this is the red channel. So red should be between 180 and 194. And then keep going. Do it for this is the green channel, and then you go and look for the data tip here. Anong value nito? Natakpan ng data tip nito. 170 hanggang 157. And finally, yung blue. Data tips tayo sa blue. Paki-note ha. 170, 157. Okay. Lastly, ito. 81 hanggang, ito? 40. Ganito nag-stay. Okay. Yon, ayos na. Papalitan lang natin yung ginawa ko kanina. Okay, sige. Next, ito na. Thresholding na. Simple thresholding. Yan. Okay. So, for the red patch, ito yung, ito yung ginawa ko. But now, we will just do for this. Okay? Alright. Teka, sulat ko na lang. So, to threshold, sasabihin natin, this is the way, no? We will make a black and white image, black and white, and we will use logical operations to threshold. So, okay, siguro, sandali lang ha. Now, I think I need to now convert the image I into RGB. So, una muna, i-separate ko muna yung the whole image I into the RGB channels. Parang ganito lang guys, parang ginagawa lang natin dito, but do it for I. So, colon 1, G equals I. Pag sinabi mong colon sa MATLAB, all rows, all columns, and then you choose the second channel for the green, and B equals I colon 3 for the red channel. And the trick is to do logical operations and put it in a black and white image. Because it's logical, it's just 1 or 0, true or false. So that's why it will appear like a black image, like so. So let's try yung red channel muna. Anong sabi sa red channel? 194,180. So all R's less than 180. Okay? Pero i-end natin yan. So there is a logical end operator, a single ampersand, and R greater than mali. Sorry, baliktad. Or R's less than 194 but R's greater than 180. Okay? And then we can just simply show this in another figure 3. Okay? Show PW. Yan. Alright? And then let's run this section only. Now, look at that. Hindi na-isolate yung object na nakuha natin kanina. Meron pang sumama dito. And it's because we're just using the red channel only. So, dagdagan natin ng green channel. So, pati yung sa green, lagay natin, G. Ano may sabi sa G? 157. Greater than 157 to 170. So, all G's greater than 157. And also, all G's less than 170. So essentially, ang sinasabi natin is mag-true yung pixel sa location na yan kapag na-satisfy lahat nitong conditions na to. Okay? Kasi end eh. So, dapat true lahat nitong condition na to para mag-light up yung pixel location na yan. Remember, R, G, and B have the same dimensions. Okay? So, they will fall on the same spot. Let's run again this section. Okay. It seems enough na yung R and G sa bagay kasi yellow naman to eh. And a yellow colored object is just green, red and green. Of course, you can do completeness by doing this, by including B as well. Okay? B greater than 40 and B less than 81. Okay. Yan. Semicolon pala kaya nag-show. So, run section again. And this is what we have. Okay? It's nearly similar like what we got earlier. So, play around with this thresholding. Now, the question, how do you know kung yung ano uh, yung size ng imcrop mo? If we contextualize it into this simple example, how much of the sample should you crop? So the idea there is the more the merrier, the more the better. This matters, Romel, if your image is not as flat as this image, because this is flat, this is matte and flat. Pag rounded or shiny, ang object mo, 3D yung object mo, you might need more samples. Okay? So short answer is the more samples, especially for rounded and shiny object, the more samples you can get even on those shiny and rounded parts, the better. Okay? Wanna try it again? Mahirap lang mag-thresholding eh. Okay? But that's my answer to you, Ramel. Now, another thing that we can take a look at. Other questions, by the way? Did I answer your question, Romel, satisfactorily?
Yes, ma'am. Quick follow-up lang din po.
Yeah.
Yung values, yung range of values for RGB para sa thresholding, in practice, saan po siya kinukuha?
Dun sa histogram. The second section that I showed here, di ba may picture dito? Ito to. Here, we cropped the image. So let's go through this code. We first crop the region of interest. This is all, you will do this over and over again. You will crop first a region of interest. And then, in lines 10, 11, and 12, I use the imhist function to display the histogram of each channel. Di ba nga? So,
Yes,
ito yung lumabas nun.
sorry.
Okay?
Sige pa. Opo, ma'am.
Yeah? Ito yung tinitignan natin kanina. Sabi natin, ito yung range niya, ito yung range niya, ito yung range niya. Okay? This is taken separately. Kasi mas madaling tignan dito kaysa sa 3D image. Ever wonder how it looks like kapag 3D yung pixels na? Well, I think we can do that. Let me see. Okay. In MATLAB, there is a function called plot tree. Tingnan natin kung i-display natin. Okay. Sige. Tignan natin in 3D itong histogram na to. But I guarantee you, parang papatong lang siya kapag same. Hindi natin nakikita yung intensity or rather intensity, the number of pixels in this case. Makikita lang natin may pixels lang doon sa location na yun. But bear with me. This is just quickly. Okay? So, yung RGB values nandito na sa RGB, no? So, there's a function plot tree in MATLAB. Let's open another figure window para hindi magpatong-patong to. Okay? Plot tree. And then, R. Pa-plot natin yung R, but here's a trick. you put a colon in parentheses, and that means it concatenate na yung R. If you don't, it seems like a 2D image. Okay? So we also do that, concatenate G so that it's a whole column. And do that for B as well. And then you choose a red dot to represent these points. Okay? That's it. And I think that's it. Okay, let's run this section. And it looks like this. Tchadan! Ay, joke. Ah, tama. Ay, hindi. Teka muna, guys. Ito yung histogram ng buong image. You see this? This is the histogram of the whole Macbeth chart. This is how it looks. Okay? Ay? Want to see the histogram of a single patch? Okay. Mali yung ginamit ko eh. Nagamit ko yung yung R. The RGB is that for the whole image. So what if we want to see yung dun sa patch lang? Okay? Oops. I think I need to do this. Saglit lang guys ah. Copy this. Put this here. And the crop patch is J, so I'll just put a J here. And I'll just put J here. This is J is the variable where we put the cropped yellow patch. Okay? Joke. This is G, J. And then, don't forget, this should be J, not I. And then this is V, small j, and this is J. Again, J is the crop image. And don't forget, let's put the subscript J, image of this. And let's have a look again at this. So this is the yellow patch. Yan na siya. That's it. Notice that this doesn't go to max, paano nga ba mag-max dito? Axis, ata eh. 0, 2, 5, 5. Kailangan ko may help axis. Ano nga ba yun? Just so we force the axis to be, 0 to 255 in each section, in each axis. Axis min, x max, y min. Okay. So, ganito ko lang po. So, for that image, I just put sabi na? Okay, in square brackets. 0 to 255, 0 to 255, and 0 to 255. Square bracket. There. Then, if we inspect the image again, and now it is in 0255. RGB. So, this is the red axis. This is the G axis. Tama ba? Oh no, wait. I'm not sure. Asan ba yung XY dito? Let's look at the, let's rotate this in 3D. Just to get an idea kung ano yung, ako, naghang na ata, Lord. Ito lang guys, Ayan. Okay. This is clear. This is red, and this is green. And this z-axis is blue. Okay? So if we look at it this way, we are looking at the x-axis is the green axis and the y-axis is the blue. Tama nga naman, yellow, wala masyadong blue ang yellow. If we rotate it this way, we're looking at blue versus red. Okay? We rotate it this way, we're looking at red versus green. And yellow indeed is a mixture of red and green light. And in 3D, you see it here. Okay? So, Romel, try this procedure on round objects or objects with volume na meron pang shading. And you will see that it's not a simple blob. Okay? So, ito yung sinasabi ko kanina na in simple thresholding, we're just, putting straight boundaries on the red, green, and blue channel. In the second case, we're using parameters, no? So we can actually fit a Gaussian function on this and make it more, make it better, no? Make it more tight. Okay? By the way, recall in the text, sabi ko doon, hindi ko na sinulat dito, but if you want, you can attend the tutorial on Friday. I can sponsor a tutorial on Friday how to do this part. Okay? So multivariate Gaussian naman. In this case, you will fit an ellipsoid on that. No. In this case, the multivariate is a pixel having RGB values, 3 values. The mean also would have 3 values. And the covariance matrix should be 3 by 3. Alright? Okay? So, you will, after calculating, so, Romel, di ba, kinuha mo yung yellow patch or yung red patch. From that patch,
Yes,
you will
ma'am.
calculate mu and sigma. Mu is vector, which has 3 elements. Covariance matrix is 3 by 3. The diagonal of the covariance matrix is the variance, or square of the standard deviation of the 1D histograms of each. You can check that. And then, once you're done parameterizing this blob here, you can go ahead and plug these values here. So pick a pixel, each pixel which will have an RGB, subtract that pixel RGB from the mean, transpose this vector, multiply by the inverse of the covariance, multiply by, bliktad, ganun pala yung process. Get the difference of the pixel value by the mean, then multiply by the inverse of the covariance vector, then multiply by this transpose. Okay? It will be a scalar. In the end, it will become a scalar. Then you apply exponential, and then you divide by this constant. And the output is a number between 0 and 1, which tells you how likely the pixel is, the pixel belongs to this distribution. Diba? Gets? Yon. So, parang apply mo lang to so, sa bawat pixel. Malinaw?
Yes, ma'am.
Okay. Lastly, yung favorite ko, non-parametric. Kasi hindi naman ganyan ka-behave ang histogram actually, colored histogram. Lalo pa kapag multicolor. Yeah, we can actually segment objects that have more colors. But we can, as I said here, sure, you can have multiple thresholds, or sure, you can have Gaussian mixture models. That can be done as well. Why not? But instead of looking for the threshold and looking for the parameters, why not just use the histogram itself? And that was what I was telling earlier. If you can express the histogram, okay, then you just back project per pixel. And the technique that is shown here, mahirap kasi pag 3D RGB, and then you have, it's difficult to access the fourth dimension, which is the frequency of the pixels occurring with that RGB value. So this section teaches you na, okay, we can actually display our colored image in a reduced color space, the normalized chromaticity coordinates. Take a pixel, add up their RGB, so it's a single value, and let's call that intensity. Then take the pixel again, divide its R value by I, then you have a normalized red value. Do that for G and B, you have a normalized G value and B value. Okay? And you can show that this will be a number between 0 and 1. All of these normalized values will be number 0 and 1. And when you add them all up for a certain pixel, they equal 1. Okay? And because now, hindi na 0 to 255, instead it's a number from 0 to 1. And actually, this, since B is dependent, I mean, given this equation, you can see that B is dependent. If you know RG, you already know B. You don't need to display B, therefore. So you can actually transform a colored image into another color dimension, small r, small g, and capital I. And if you ignore the I, you don't care about the brightness levels anymore. You just look at the chromaticity levels. So if you plot RG, it looks like a color triangle, and this is the R axis, this is the G axis. Parang siyang color wheel pero naging triangle. And as you can see, if R and G is equal to 0, you're left with B. Okay? And mas madali nang tignan yung color histogram dito because now it can be imagined as 3D. So, small r, small g, tapos yung patches dito, kung mataas yung value dito sa bin na ito, yun na yun, yung papalit mo. Okay? You can imagine this in 3D. And the back projection will work as well. So, you have your color histogram, you convert it into normalized chromaticity coordinates, you plot the intensity of or rather the number of pixels having that same RG, and then you do the same for the whole image, and then pixel per pixel, you look for the RG, and then back project the value onto that pixel. Value of the histogram onto that pixel. Okay. So no parametrization at all. The only free parameter that you need to specify here is this. Dahil na normalize na natin yung color, hindi na siya discrete. 0 to 255 originally ang digital color. Pag dinormalize natin, it's a real number ranging from 0 to 1. Now, you can specify how coarse your binning will be. You can say, okay, I'll just choose 8 bins here. So this will become 8 by 8. No? And half of it only is what you will need because wala namang colors existing in this. You can also have it 16 by 16 if you want it to be a little more fine, or 32 by 32. So a range of R and Gs will fall on a square. Okay? All right? So you are free to parameterize or rather specify how many bins you would have for the R, small r and small g. So para natin ginawa siyang blocks, no? Okay? I'll send sample codes. Ite-test ko muna kasi originally they were in Scilab. A free clone of MATLAB. Okay? But I'll send codes after this. Other questions? Wala na? Okay. Okay kayo sa Romel? You're still raising your hand, Romel?
Ay, ma'am, quick question lang about MATLAB.
Sure. Yeah?
May recommended toolbox po ba kayo for...
Okay. So, let me demonstrate na you can actually... guys, naka-install na ba kayo ng MATLAB? For image processing toolbox is one, and later yung computer vision toolbox. Okay. Go to mathworks.com. Okay. Ako naka-login na ako dito eh. But when you're asked to get MATLAB, log out. Okay. If you haven't gotten your MATLAB, go to Get MATLAB. Get Campus Software. Yo. Okay? And then, put your university name here. University of the Philippines. Yan. And then, put your email here. Okay? Ay, nagawa ko na eh. So, sure ako. So, na-recognize niya na meron nga akong ganyan. And then, right away, may access na. Okay? And then, once you get into your own MATLAB account, teka, saan yung sign in? Hello? Sign in. You can... Okay. In fact, I use... yung password natin sa UP-Edu-PH. Forget this. Ano kung bakit? Kasi recognize na ako. Ting! Nandiyan na ako. So, I can go to my account. And then, you can check out MATLAB online. And then, you have the option to either do this on MATLAB online or install MATLAB on your computer. And then, when you install, you will be asked kung ano yung mga toolboxes So the toolboxes that I recommend are image processing toolbox and computer vision toolbox. Saan ba yung PCA? Can't remember kung saan yung PCA. Let's have a look. Also, kung hindi, I'm trying to check kasi kung baka hindi lahat powerful yung computers nila eh. So in which case, baka hindi ma-download yung MATLAB. Or rather, sorry, ganito. Some of the programs here are, or toolboxes here are not available offline. Online. Like, I noticed that meron dapat siyang volume viewer while I was testing for 3D imagery, yung mga MRI sections, no? When we get to that activity, tinetest ko yung volume viewer niya. Tapos ang error code na lumalabas is hindi kaya sa MATLAB online. So you have to use the offline version. Okay? So there. Then you can search the documentation. I don't know, maybe you can have a look at the toolboxes. Okay. So kung may iba pa kayong activities na gustong gawin, actually marami siyang toolboxes. Yeah, so image processing and computer vision toolbox. Gusto mo ba ng artificial intelligence, data science, and statistics? May CNN dyan. Yes. Bet mo ba ang robotics? Meron dyan. Yes. Control systems. Yes. Signal processing. Yeah, okay. Signal processing, may mga importanting tools dito. I think we can use some wavelet. Yeah. No, so may PCA. Remember. Statistical ba yun? Balik tayo. I think embedded na ata. I'll let you know. Anyway, you can install toolboxes at a later time. But this is what we need for now. Image processing, computer vision. You might want to, for your personal use, download this as well. And mathematics and optimization. May gaming pa. Okay? Yeah, and it can also do parallel processing if if you have several cores. Okay. Other questions? So for now, image processing, toolbox, and not signal processing, not yet. I'll let you know if you need any more. Minimum is image processing and computer vision.
Okay
If
po,
you're
ma'am.
new
Thank you po.
to if you're new to MATLAB, as I said, you can go ahead and try out their courses. Okay. So if you want to learn more, there are several courses here, and some are free, some are not. And you might want to do this, MATLAB Fundamentals. Okay. You want to go deep learning, they also have, not all are free, it seems. So just check. You can go ahead also and learn on your own some image processing. Okay. All right. Getting started. So several courses here. Okay. Okay. Hindi ko pa nakikita to. Ano kaya meron dito? Start course. May bayad ba? Baka wala naman. Self-paced, oh. So, yeah. Start course. May bayad ba? Wala. Wala eh. Wala naman. Sige. Okay, others? Other questions? May tanong pa ba? Let's look at the chat. Uy, may video. Wait lang. Stop muna. Teka. Wait. Stop share. Okay. Wala nang tanong, guys? Malinaw po ba lahat? Kung wala nang tanong, I leave you to your exercise. Okay? And that's it for today. Thank you very much.
Thank you po.
Okay, bye.
You
Ma'am.
Okay. Keep looking at the for other additional files that I might be uploading. Okay? Bye. Bye.
Bye, ma'am.
Bye. Ah.
Thank you, ma'am.